What we are working on today is the graphics system. And I've done some reading, and we're going to start off with a very simple way of drawing the screen. And for that I built here two functions: draw background and draw sprites. And I think I need twice of each of those. We'll start with this because I will show you. If you have a look at the video memory after our last run, memory dump. Our video memory is at 8000. So that's right over here. You can already see that there is some stuff in there, and that stuff will be displayed on the screen, and then it will be translated. So what for now I'm going to do is I'm going to read all this memory. I think it's up to something like 9000, and then display it on the screen, and then I think it needs to be translated to the screen to a certain point, and that's determined by a couple of registers. And so that's what we are doing. Let me just quickly check. Those are the scroll X and scroll I registers. Let me search for that. Scroll X. Well, I don't know where those registers are. Here we can see here is our video memory. I don't see the scroll. Scroll X and scroll I. So we can also have a look at that. So that's FF42 and 43. FF 40, 0, 1, 2 and 3. So at this point there's no scrolling going on. So let's come back to the video memory. And you can actually see there is some stuff in there. So very interesting if we can see what exactly is in there, and I'll show you quickly how you can see what's in there. So here are those bytes from video memory. So this is 8000, 8001, etc. And then that will get mapped into memory more or less like this, where each of these this is one tile. One of these blocks is one tile, 8 by 8 pixels, and this is the second tile, 8 by 8 pixels. And the intensity of the pixel, so there are 4 colors. There's like blank, there's 1, and there's 2, and there's 3. And those get determined by the sum of these two bits. So this is 1 and 0 is 1. And if this one is 1 and this one is 0, then it's 2. If they're both 1, it's 3. And if they're both 0, it's blank. So I've started with the first function here, draw background. and we'll see if that's going to work. So here, what I wanted to do is I read the first 2 bytes from video memory. So that is here, I think. And then at those 2 bytes, we're going to read the pixels. So, and the pixel will be well, it will be this plus this. And to do that, we do this. I loop over the first 8 bits. Draw pixels from bit 7 to bit 0, left to right. And then I'm going to mask, or yeah, I'm going to shift the pixel. So I'm going to shift the first byte, that is the line, and line is something like CE00, for instance, or just some random, to make it a little bit more clear what I am doing. So I need to shift this pixel to that position. So I shift it by J. Well, I need the second one, I need the first one. So first I'll make 2 bytes of this. This line 1. Well, I just read byte. And read the second byte. And these then can jump by 2. So line 1 shifted to the right by J. So that will do something. If we have this, if we look at this byte, it will shift to, let's say 1, 2, 3, 4, 1, 2, 3, 1. So this bit will be now over there. We do the second thing for the other line. So line 2 shifted by J. That will be this bit will be shifted to that position. And then we can sum those. Sum pix1 plus pix2. And now we can pick the color. So if sum is 0, then 1, 2, 3, 4, color is I'll name it something like this, is white. Else if sum is 1, then the color will be light gray. And if sum is 2, color is dark gray. And else color is black. Okay, and then I need to actually display that pixel, and I will do it like this. Self.win.plot, and this is x, y, and color. I'll show you the documentation of that. No, this is not it. This one. Yeah, here's the documentation of the graphics library. I'm doing a very simple graphical stuff. I probably will be using not entries, this images. So what I'll basically do is I'll build an image using the background, and then that will be translated to the screen by a certain like move. And then I'll do the same thing for all the sprites probably, so there will be a lot of separate sprite images and they will be drawn to the screen. But for now I'm going to do it in a very simple way. I'm just going to use plot XY color, and also for now I'm going to ignore color. But what are those x and y coordinates? So if I start here with just 0 and just go to 0FFF and do here plus 0x8000 plus 0x8000, then my x coordinate will be this value modulus 32, because for each line there is 32 bytes. Am I saying that correctly? Let me get the documentation. So we have 32 by 32 tiles, and they're each 8 pixels. So each horizontal line is 256 times 2 bits long, or divided by 8 with 2 bytes per tile, so 64. So our x value is I divided by well, I already count bytes, so this is difficult. How many bytes are there in a line? There are 32 tiles, so 64 bytes in a line. So I is a maximum of 64. Modulus 64. But then I also need to address the right pixel, and that is J. And then for Y, Y is the is a little bit more difficult because I need to divide I through 64, then throw away the remainder, and then plus so it will be something like this: I divided by 64, but no remainder. So int of this value. Yeah, and just for good measure, I'm going to print out these values. So I'm going to say print drawing pixel on and then I'm going to say this value, so 2 decimals, 0 will be a D, and this one will be also a D, and then these two values. So that's pasted in, all right. Let me bring the chat up. So yeah, the color, I think I need to do something with the color. So how do we do a color? Generating colors. Okay, that's cool. Color underscore RGB. So we can prepare all of those colors. We'll say white is color RGB, light gray, RGB, we can look up on the internet the like real Game Boy Color shades, because it's not perfectly black and white, but it's like a olive green and a very dark gray. Dark gray. And black. Line these up. Okay, let's look up the Game Boy Color shades. I did find it once, so it must be there. This looks fine, I think. So let's do it. 175, 203, 70, 121, 170, 109. So let's see how this will turn out. And of course it is a little bit subjective. Okay, I'm very curious to see if this will work. And just remove this. Oh, and I will probably want to start out with a nice blank white shade. So I'm just going to do a fill. Yeah. We first need to do a rectangle. Rectangle. 0 point 0 0 and a point at 256 256. And then I need to fill that thing. Rectangle dot set fill white, and then draw that thing into the window. So window draw. Draw it into this window, self.win. We don't need that one anymore. Another small error. Oh, mistake. Well, then I'll do it like this. Like I do with most of my things, I'll make it a property of this object, which I don't think matters that much. And then of course I need to do self.white, and then also here non-type has no attribute draw. So that's annoying. So the fill does not return our rectangle. And we'll do this, rec.setFill, rec.draw. Oh yeah. It is doing something. But it's not doing it completely well. But we can figure out what's going wrong. So we had that black square. That was probably an issue because I don't think I used, and none of these are like really black. So probably want to go up here. And I'm going to interrupt it as soon as it, yeah. So it's doing something a little bit weird. It should be drawing like 0, 1, 2, 3, 4, 5, 6. No, it should be drawing like let's go have a look. So what be handy to do this and to give it a padding of 3. So we can exactly see what pixels it is drawing. You can see it is drawing but it's only drawing up to 64, which could make sense because we divide our modulus by 4. Now GPU. So what I think I might have done wrong is I need to multiply the byte we are currently doing by 8, the position of the byte. Yeah, I think that works. Let's try that. Yes. Something's happening. So it's drawing on really weird 6 5 4 3 2 1 9 8 7 6 5 3 4 3 11 10. And this should just count up from 0 to I want to count it up from 0 to 2 5 6. I'm using J, and J is actually going the wrong way around, so I actually need to do 8 minus J. So it will be, instead of what it is now, it will be from 7. So I wanted to count 0, 1, 2, 3, 4, 5, 6, 7, and this one will be, well, this one will bump up 1. So, and since J starts at 7 and goes to 0, it will be 7. It will actually do that. So let's see how this goes. So how does this count? Goes up to, it counts really weird. Need to increase my buffer. Let's make it 400,000. So let's get my other terminal going. So we start at I will be 0, so that's fine. J will be 7. That's also fine. So I want X to be 0. So I mod 64 I think that will be 0, because else it will be, if it was 1, then it would be at least 8. So let's assume this is 1 times 8. 0 times 8, still 0, plus 7 minus j. J should start at 7. So then it would be 7 minus 7 is 0. So that should be 0. And then the y value is just, yeah, it's nothing. So that's good. Why this is working. This is the problem. So let me just add I want to know what I and j are. I did do j. And why does j become suddenly so either something is up. Is j, oh I see already. Mistake in the print. Let's go to the top. And look at our function. So I should not increase until these 8 pixels are drawn. So 1, 2, 3, 4, 5, 6, 7. That's not correct, because it doesn't do 0. And this should be good. 7, 6, 5, 4, 3, 2, 1. No, that's actually not what I need it to be, because I need it to be 7 minus J. And J is 7. So what is this? Let me just see what this part is. That's 4. Let me just annotate this a little more. X, Y. Then we have I, J. Now we have XP for XPlot. Well, not entirely X mod. So let's run it again. Wait for it. Interrupt it. So, what has been going on here? First it's 0, 0, 0, 0, 0, and then suddenly it's 16, and I think that is actually correct. So this is 0. That is fine. I think this should actually divide by 2 again, because I takes steps of 2, and then why doesn't this work? 7 minus J. J is 7. So 7 minus 7 should be 0. Maybe feed another parenthesis. So 7 minus J is 0. This whole thing is 0. Space there. So I modulus 64 should be 0, times 8 should do nothing, divided by 2. So this should dump to 0, 8, etc. Okay, it wants to make a float. That's not nice. So 1, 2, 1, 2. This closes that one, that closes that one, that closes that one. And those are the print statements. That closes. Oh, put it in the wrong spot. This is correct, I think. this should go here. Or we can just copy this thing again. Yeah, I think it's the same. One open, two open, three open, 4 open, 5 open, 4 open, 3 open, 2 open, 3 open, 2 open, 1 open, 2 open, 2 close. I thought I fixed this. Alright, so it's just about the syntax. So maybe we need to make this a little bit more simple by cutting some stuff out. So we do I mod 64 divided by 2. Well, if I just lose this one, just modulus 32, that would work. So this is all fine. I mod 32 close times 8. Yeah, this makes sense. And then I actually don't need these. Let's run. What is happening? Y 0. Still the same issue. 7654321. I just don't understand. I mean, 7 minus 7, that's... Yeah, it really is J. 7 minus J, come on! Just want to make sure that That is what I think it is. Why doesn't print out J? Here we are. I'm not getting why 7 minus J is not 0 the first time. It's just like, why is not this working? So here we are. Yeah, 7 minus J. That is a thing. That is working. But I don't know why it's completely baffled. Because this is the same thing as over here. I mod 32 times 8. And then this is for some reason just not. I'm calling it J in, like inverted. I'm just going to print it to be completely sure about it. Come on, where are you? So many pixels. So this is still cool. This isn't. Wait. Of course I need to take this into the new print. And then that will sort out all my troubles. Yeah, zeroed through 7, and then it suddenly starts at 16. That is weird. I mean, yeah, we should count 16. No, we should not count 16, we should count to 8. I mean, we do 2 bytes, and then so actually we need to modulus 16. And then let me just remove all this junk. Got it here. Got it here. Turn this back into 7 minus j. So like this. Scrolling back up. And we'll see what happens. Pixel 0, 1, 2, 3, 4, 5, 6. Still 16. Oh, that's right. Still doesn't look right. Hi Manu FV. We still have these jumps. Does it mean we just need to do 8 here? So what's happening here now? So I'm going to think a little bit more about which byte we are currently writing to. So I is the byte that we are currently reading from memory, and it takes steps of 2 because we write 1 byte, and then that uses, we write 8 pixels and it uses up 2 bytes. So I jumps to 2, and then we write the next byte, and then we write the next byte, and so it's more like I divided by 2 times x. Then of course when it loops around, we need to handle that. So I keeps increasing, and once we get past 64, past 256, then it will jump again. And we need to use int. And stop it. A little bit higher. Yep. Here we are. So, damn it! I always forget to update our print statement. So what we do now is int divide by 2 times 8. We get a nice blank screen. And we look at the pixels. Where are they? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that goes well. And it should go up to 2, 5, 6. And then come back around. So up to here. Yeah, so we need to modulus 64. Modulus 256. So it never gets higher than 256. And because we have to divide by 2 times 8, I'm going to make that times 4. This, one of these, times 4, and do the whole thing modulus 256. So it will jump to the next line again instead of continuing. Put it there. Just watching to see if something actually happens. Because we effectively slowed our system quite a lot. And of course, as is tradition, I forgot to update the print statement. have something on the screen yet? No. Stop it there. So we go up to 256, 255, yeah, up to 255, and then back to, well, not back to 0. It continues. How is that possible? I mean, percentage is the modulus operator, right? Python modulo. Yeah, it is. Thanks for for adding that. So the big question is, why is this still flowing over 256? Because that should not be possible, in my own opinion. Get rid of this. I times 4. I don't know what to do except for place more parentheses. Oh, maybe it does something weird with this. So, put it there. Like this. Hey, did something. So let's have a look what it's doing. That looks better. Y0 incrementing to 255 and then back to the first pixel. Okay, so that's good, but what about the end? Yeah, because y is now only counting up to 63 and not counting up to 256 as well. And I think there's a very simple reason for that. So I messed up my calculations from before. So we have 256 rows of pixels, and well, I have 496. 16, yeah. Major mistake. Whoa, that's weird. That's a weird thing. Well, at least it's filling the entire screen now, so that's good. And now, a more interesting question is, what pixel are we actually drawing? So which of these colors are we actually drawing? And I and J, I'll believe that. I'll make this a string. And what I'm going to print out is which color is being printed. Because so far nothing's really happening. Well, something is happening, so that's interesting. But not a lot is happening. Maybe because it's way too slow. So let me just remove the debug. It seems to be writing only this color, AFCB46, which is this gray, color, but it's not actually doing the right thing. So let me just scroll up to the previous write out. Yeah, it's not working out as I had expected. Because yeah, it is working up its way until the right pixels, but it is not writing the right amount of pixels per line. Because if you look at one line, which starts here, for instance, 250, it starts at 128, and this is then, well, it starts at 128 and doesn't start at 0. And which one is AF? Hex to decimal. AF is 175, and 175 is white. So it's always thinking sum is 0. At least usually it is. No. No, it's not always writing the same color. Sometimes it's writing another color. But still, it's not doing its job right. It's only counting up to 64 and not to 256. Well, I guess I have to figure out what I am doing wrong here. But I want to thank all of you for joining me today in the chat as well and on the stream. That's always very nice. So I will be back sometime, maybe the next week on Monday, maybe in the weekend. I'll figure it out, and have a nice day, everybody, and see you next time.